A DNS example. Let's say that you type the URL www.howstuffworks.com into your browser. The browser contacts a DNS server to get the IP address. A DNS server starts its search for an IP address by contacting one of the DNS root servers. The root servers know the IP addresses for all of the DNS servers that handle the top-level domains .com, .net, .org, etc. Your DNS server asks the root for www.howstuffworks.com, and the root would say, "I don't know the IP address for www.howstuffworks.com, but here's the IP address for the .com DNS server." Your name server then sends a query to the .com DNS server asking it if it knows the IP address for www.howstuffworks.com. The DNS server for the .com domain knows the IP addresses for the name servers handling the www.howstuffworks.com domain, so it returns those. Your name server then contacts the DNS server for www.howstuffworks.com and asks if it knows the IP address for www.howstuffworks.com. It actually does, so it returns the IP address to your DNS server, which returns it to the browser, which then contacts the server for www.howstuffworks.com to get a web page. One of the keys to making this work is redundancy. There are multiple DNS servers at every level, so that if one fails, there are others to handle the requests. The other key is caching. Once a DNS server resolves a request, it caches the IP address it receives. Once it has made a request to a root DNS server for any .com domain, it knows the IP address for a DNS server handling the .com domain, so it doesn't have to ask the root DNS servers again for that information. DNS servers can do this for every request, and this caching helps to keep things from bogging down. Even though they're totally invisible, DNS servers handle billions of requests every day, and they are essential to the Internet's smooth functioning. The fact that this distributed database works so well and so invisibly day in and day out is a testimony to the design. Internet servers and clients. Every machine on the Internet is either a server or a client. The machines that provide services to other machines are servers, and the machines that are used to connect to those services are clients. There are web servers, email servers, FTP servers, and so on serving the needs of Internet users all over the world. When you connect to www.howstuffworks.com to read a page, you are a user sitting at a client's machine. You are accessing the HowStuffWorks web server. The server machine finds the page you requested and sends it to you. Clients that come to a server machine do so with a specific intent, so clients direct their requests to a specific software server running on the server machine. For example, if you are running a web browser on your machine, it attempts to talk to the web server on the server machine, not the email server. A server has a static IP address that does not change. A home machine that is dialing up through a modem, on the other hand, typically has an IP address assigned by the ISP every time you log on. That IP address is unique for your session. It probably will be different the next time you dial in. This way, an ISP only needs one IP address for each device, rather than one for each customer. Ports and HTTP. Any server makes its services available using numbered ports, one for each service that is available on the server. For example, if a server machine is running a web server and a file transfer protocol (FTP) server, the web server would typically be available on port 80 and the FTP server would be available on port 21. Clients connect to a service at a specific IP address and on a specific port number. Once a client has connected to a service on a particular port, it accesses the service using a specific protocol. Protocols simply describe how the client and server will have their conversation. Every web server on the Internet conforms to the Hypertext Transfer Protocol (HTTP). You can learn more about Internet servers, ports and protocols by reading how web servers work. Networks, routers, NAPs, ISPs, DNS, and powerful servers all make the Internet possible. It is truly amazing when you realize that all this information is sent around the world in a matter of milliseconds. The components are extremely important in modern life. Without them, there would be no Internet. And without the Internet, life would be very different indeed for many of us.